Save as, save as, whatever you want to share. Come on, do.
No, we should close the gap up. I'm going to take the projections back.
Whatever it's going to say. Okay, appreciate it. Okay, now we're going to move this, we're going to close it. Okay, these, not just the top one.
How did you close the gap? Did you just explain that?
There was no number over.
Okay, so how did you get that number?
You click on here, you take that little dot, drag it up.
All right. And same with the other one?
Then I, then that drag this one up and you're good.
All right.
Good.
Projections lower than you don't know.
Mine is hours of doing just the estimate projection.
That is
Yeah.
paying attention and that's expensive scotch.
I also heard
Thank you.
I'm sure I did
For the last
something
year,
something's going on. They'll call me and now first seat.
it's actually going to be less than historical.
Did you guys? That's what I did.
I know, that's the thing.
2005, 2008, that's really corresponding. And then, one part. Why do you keep on going to general, you asshole?
GDP per person, per capita.
Yes, that is fine.
Right?
Do the next one. Now.
2005.
Oh, did you put out?
Year again?
Yeah.
There's a mistake.
I can't hear you.
A mistake. The number.
And then this is your thing. And let 43.5317 plus. I should do that right.
So there it is. Notice the historical data kind of strange. That dip that comes about because there was a dip in the population exploded there. And there was a dip in the GDP. But the trend is like that. If you notice the trend goes right through that. In fact, I should do the trend all the way. Let me do the trend all the way so you can see why that trend is like that.
So you drag the trend up?
Huh?
Drag the trend up?
Yeah. This is a better way to do it. Now you see. You see what the trend does? It goes right through the middle of the historical data. So this is the way I want you to do it. With the historical data going like that, you start going like that. But you only go out to the year 2035. Don't go out beyond that. So let me put that in there, we'll see how it looks.
You wouldn't remember that. Check your phone, really.
Is it 2035?
It looks exactly like mine. Looks exactly like mine.
Yeah.
Big number.
So,
It's 100% wrong.
I have a question.
Now, you want to adjust this.
I swear to God, I did it right on mine. I didn't know what kind of When we do this, when we do this, we've done Is it, is that right? Oh, you did, yeah, oh, you did log, not LN. You were looking for natural log. Okay. It's so different.
It goes like that. It's short. Another way we can do this
Which probably actually goes further.
would be to
That's
just
one of
take
the
this.
crazy numbers that just not in this, right? Change the number up there and just.
Oh.
Put it all over here. All right, control shift. Well, here that works here, and then that goes down.
Let's put that in. Gives us essentially the same thing.
Yeah, I guess what else doesn't Don't know myself. Oh my God. Okay, let's just say this.
But anyway, that's basically so you see the trend in per capita income current way up to 2035. Just take the sharp turn after 2035 because when things are moving exponentially, it's sooner or later make a sharp turn up. And you can never really project too long with an exponential because that sharp turn would take you to never land. But you just want to get it before it really starts moving out of the market. Huh? Yeah. It's exponential.
I have a problem with Bulgaria. It actually goes down to 0. It's decreasing.
Which one is this?
Bulgaria. The line is actually GDP per capita is decreasing.
The population decrease?
Yeah.
That's the reason?
But I have 2010 I have 3,200.
Well, something's wrong.
Yeah.
The population is decreasing, right?
Well, it
The
looks
GDP increasing or decreasing?
the population is decreasing.
Population is decreasing.
Yeah.
And the GDP is increasing?
It's sort of constant.
Well, then if your population decreases, it should be going up.
It looks like I did the regression right, but when I do the projection, it really lowers the estimates, like right off the bat.
There's something wrong. Bulgaria. if that's happening.
That's the, what else?
It should be increasing if the population is
Right
decreasing.
here. Well, first you
As
have
long
to
as
go
the GDP is not increasing, it's not
historical
decreasing.
five. Paraguay GDP per capita. Just the fives and tens. You make my head.
So this is what I want for homework next week. We're going to go through it and make sure you get it right.
For our assigned countries,
For your assigned country.
okay.
GDP per capita.
What else did we need for our assigned countries? Anything else? Was that it?
That's it.
Okay, that's fine. I'm not gonna ask to do anything else. But you want like this, you want a trend line with the actual?
Yeah.
Okay.
Just like this.
That makes me
If the
happy.
blue is the actual per capita, and the red trend line is the fitted per capita.
Okay, done.
Okay?
Got it.
If you did it now, you don't have to worry about it next time.
No, not 96, 95, but it's 19, 95, 2000.
But I just taught you a very important thing, how to get an extrapolation,
That's 2000.
That's right, that's.
how to extrapolate. I just taught you something very important, your toolkit, for your job.
No, that's helpful. It is. It's actually not hard when you do it.
Huh?
It's not hard. Like, you know, it's just, I had no idea where you got all your numbers.
This is what we call an extrapolation. Now, you might argue that the world does not really work on extrapolation, but it works on cause and effect. What will happen in the future, in the case of Paraguay, will not depend upon this extrapolation, but what happens, for example, to their economy. And their economy is driven by capital. The more capital they have, the faster their economy is going to grow. The less capital they have, the slower it's going to grow.
Yeah, the Illinois is supposed to be like 5 years, right?
Whatever that number is.
And you're not saying.
Where did you watch?
No, I'm talking about, I just started going down.
Yeah, I know what you're talking about. You're talking about what we call the dependency ratio. And what happens is that over a period of time, there are too few people supporting the people who retired. And do you know what's going to happen?
Where did these numbers come from?
They're going to cut the retirement benefits.
What
do you think?
That's like the people I work with, older.
They're going to get older with less Social Security.
I'm working.
And they'll raise the Social Security eligibility age.
You need to know what the
Pension
what the second CD and why other 20 years.
The Social Security Administration does that automatically. When I retired, you only had to be 65 to get a full pension, full Social Security.
Oh, he's 67, right?
Now it's 67.
How do they do that? I'm tired.
And they'll keep adjusting that as they see fit.
Oh, it was D3.
Because,
Okay,
see,
historical
when
is
people
D3
live
minus
longer,
C3.
the only thing you can do is make them work longer.
Historical. It's historical times
You can't kill them all.
Put something in their food. Like fast food.
You have to work longer. I'm 75, I still work full time.
The other one, because you're obsessed with money.
Yeah, I like that.
is equal.
The yellow one is where you
See what this was happening here? That's population per capita.
Now, I'm going to introduce you to the concept of a reduction function. This will give you for the rest of the period.
Historical per
And
capita.
the idea of a reduction function is to take factors of input
Actually dragging more.
and relate it to output.
Should I see? Yes.
Everything was
Everybody follow that?
No.
The idea of production function is take back from production, input factors, related to output. Output is the things we produce. At the micro level, we'll take the factors of production, land, labor, and capital, and produce,
I didn't do it.
we equate it to the number of units that we
I screwed
produce.
up.
Okay.
At the macro level,
Hey.
we take the factors of production and relate it to, guess what?
Like,
GDP.
okay.
That's a production function at the macro level.
Good upstairs?
So,
Is this two copy it? It's being production function.
the reason why we want a production function, because now we don't use an extrapolation to project forward on GDP, but we'll use what we think we have in the economy to project forward. Yeah. This is a macro production function. So we'll have y, there can be some function of labor and capital.
Oh, yeah. Just, yeah.
L stands for labor,
Is our capital.
capital.
Why is that not C? I never understood that.
What's missing in this?
Land.
Land.
Yeah.
It is.
A lot of people nowadays say, well, it's not really missing because it's irrelevant. You don't have to have it. For example, the Japanese have no land. If you look at Japan on the globe, it's a little tiny place. If you go to Japan, all you see is mountains and rocks. They can't grow anything there because there's no real land. The Japanese are required to get their food from outside of their borders. That's why they eat a lot of fish. They go outside their borders and get it. They do grow a few things, but not enough really to make them satisfy their hunger. So the Japanese are very dependent upon importing food. They don't have land. And they have very little in terms of natural resources. Very little in terms of ores, things like that. But still, they're very productive. And why is that? Can anybody guess?
Education?
Because they have a highly skilled, intelligent workforce. And if they can buy all the land they want on the land markets. They buy their energy, they buy their ores, they buy their food. But in order to pay for it, they gotta produce something. So they buy the raw materials, they put value added on it, and they go back and sell it out again. And this is how they exist. So land is not that important anymore because land is mobile. We used to think in economics that land was not mobile, but it really is mobile. Real estate is not mobile. But land includes other things besides real estate. It includes ores, all kinds of natural resources, and all of that can be shipped and moved around the world. If you want to really see that in action, all you have to do is go to a Japanese port, see all the raw material coming in and all the finished products going out. So we used to argue that land is not all that important, so forget about it. The only thing that's important is labor and capital. Now, if you do that, then you get to what we call the neoclassical model. The neoclassical model is like this. Y is equal to some constant,
Yeah.
A, labor to the alpha power times capital to the beta
Beta
power.
power, which is 1
This
minus
is what we
alpha.
call the the neoclassical model.
Cop number 2.
Now, if it turns out that if
I'm not sure why.
alpha plus beta equals 1, that turns out to be the case, then you have the so-called top double function.
Yes. Because beta should be 1 minus alpha.
If they're not equal to 1, then it's not a coupler.
How do you know which one to use?
Oh, no.
So you have to first find out what alpha beta are. You look at it. If alpha beta turn out to be 1, then you call it a coupler. If alpha and beta turn out to be less than 1, you have what we call decreasing returns to scale. That means if you double your labor and double your capital, you won't get double your output. If it's greater than 1,
Mine is not very increased. I'll show you.
Otherwise, this will be the equation. The way we get the equation.
if alpha and beta are greater than 1, you get increasing returns. That means if you double your labor, double your capital, you get more than double the output.
Yeah.
This is the LMY of the
It's increasing returns to scale.
Now, there's a big problem with the neoclassical model. There are a couple of problems. The one that they talk about most is the role of technology in this model. This model, as it stands, does not take into consideration changing technology for production. Some people try to get around that by adding a technology coefficient. Like that, all right? But it doesn't really make sense. You just put time, put the year in, put time to do that. It defeats the idea of a production fund. It's one thing to do it with extrapolation. It's another thing to do it with production. There was a very famous economist who used to teach at NYU, but he died not so long ago, about 10 years ago. His name was Vasily Leontiev. And Leontiev was a Russian immigrant who came to America before the war. And he had the Nobel Prize in economics.
So why are we learning the Cobb-Douglas function in my other class with an A in front of the labor as technology?
A with the T on it?
No, it's just like A, L, alpha, K, beta.
No, it's not the technology. Technology has a T on it. It goes with time. Over time, technology changes. It's not constant. Cannot be constant. The role of technology in production is how it changes over time. If it were constant over time, you wouldn't have to worry about it. Now, so that's part of the problem, is that technology is not put in there. Leontiev argued this is a silly kind of thing to do. Leontiev invented what they call the input-output table. I can show you what an input-output table looks like. We don't have time for that, but I'll show you next week. But in an input-output table, then you see what each industry has to feed to other industries in order to get the output. That's the technology.
Not vertical.
And the industries are vertical and they're horizontal.
Yes, and vertical.
Now you're talking about something else.
Yes, sir.
And then put out the table something. He's talking about a vertically integrated. Yeah, that's something else. And then put out the table shows each industry feeds into other industries. And then if you do that for all industries, if you break out the economy, say, by 1,000 industries, 1,000 tunnels, 1,000 roads, then there's a certain amount of each industry that goes to every other industry, and that is the technology under time, in a static sense. Over a period of time, those coefficients, which are called the technological coefficients of change. Now that is a very realistic approach. The problem is it takes years to build up, and it takes years and years to build up, and then put out the table for 1 year. So you have to have a modeling procedure for updating the technological coefficient. And that's what Leontief was doing before he died. Before he died, he had this big institute at NYU called the Economic Institute on Mercer Street. And he had some very top-notch computer specialists working with him. What's my name? Duchin, who's now up at Rensselaer. And they had a deal with the Society of Mechanical Engineers, where every single factory in the United States would relay their data to the Society of Engineers, their production data, weekly production data. They put it in a big data set. And then they would sort it out, or when they put out the table, it was sent up to NYU, where we lay out there to put together the technological. Enormous job. It was very useful. The U.S. government is still working on this. Unfortunately, he died. He was about 94 or something like that. He died. And the work stopped. He was teaching, but he was more into research. No, he was a very nice guy. I went to his 90th birthday in Rockefeller Center. And we became very good friends because I worked for the UN. And we gave him a big contract so we didn't put out the table a world production and the pollution that would come out of it. So we really appreciate that. But in any case, that we have never succeeded in really finishing that part of the neoclassical part. So let's take the technology out for a moment. People try it, but nothing really works. So then we look at labor and capital in the neoclassical function. Now, what that applies,
I actually want to get this.
what this neoclassical function applies about labor and capital is that they're substitutable for one another. In other words, put labor over here and capital over here. You have these isoquants.
That's dollars.
That look like this, for different levels of GDP. This would be one level of GDP, this would be another level of GDP, this would be a third level of GDP. And the combination, or different combinations of labor and capital, which would give you the same level of output, the GDP. If you were over here, you would say this is labor intensive. If you were working along this line represents the production expansion. If you work over here, you need capital. But the problem with this is it assumes that you can take more machines and less people and produce exactly the same thing without changing the technology. Once again, technology becomes a stumbling block. And Leontief argued these are not really substitutes. How do you take machines and replace people with machines? How do you take people and replace machines with people? It doesn't make sense. In fact, and he gave me a lecture about this one time, a couple of hours.